Okay, good afternoon, everybody. I'm going to give you a brief overview, as Peter said, of some of the work we've been doing in the French Alps exemplar. And as you see, that this work is actually there's even a longer list of co-authors if I wanted to be exclusive. And this is because this has been a huge amount of work, and I'll show you a few glimpses about it, trying to look into trade-offs for that region, considering a 2040 horizon. Okay, when we talk about trade-offs, we can think, and very often people think about spatial trade-offs and analysis of either things like Pareto frontiers, relationships between two services, or clusters or bundles of services. There's a number of names for that, identifying which services you find together and which tend to exclude each other in space. Less often, but however, more and more people also look at temporal trade-offs in ecosystem services, as was done here in actually an opera study, poorly known opera study yet, looking at trajectories of ecosystem services through history in mountain regions. And so people look at how, as for example, as land use and intensifies, different services trade off against each other. One last type of trade, well, there's many types of trade-offs, but one last dimension of trade-offs that people are starting to look at, including in operas, are what I would call the value trade-offs, where people compare assessments, for example, using biophysical, sociocultural, or economic dimensions. And one might say, of course, come to the conclusion that you don't get the same assessment if you use these different dimensions. Here I'm going to address the question of trade-offs in the French exemplar case study. So just to remind you, this is a moderately large area, nearly 5,000 square kilometers, over 300 municipalities, many people, 450,000 people. It's a mountain region, meaning that in fact we have a large diversity of landscapes. We have a large altitudinal range, and it is fairly dynamic, as many mountain regions in Europe, especially with, as in many other places, fairly strong urbanization over recent history, this being at the expense of agricultural land. So in response to that, there has been a very proactive planning process which aims to control urban growth and favor balanced development across the region. So in that context, we set out to operationalize ecosystem services by demonstrating the added value of incorporating ecosystem services into this planning debate, and also trying to, we gave ourselves the mission of getting people to think about multiple services at a time, in other words, trade-offs. So just to remind you about our approach, it's been presented before. We are using one likes to call a transdisciplinary research approach, where at all stages of the work we're involving stakeholders. And today I'm going to report on the scenario and ecosystem service modeling part of the work, which is now getting completed, where we are hoping with this scenario approach to give people a better understanding about trade-offs in ecosystem services in this region. So those scenarios, we use a scenario-based approach with scenarios that were co-constructed with our stakeholders, and which essentially represent a downscaling of regional scenarios called Mountain 2040. These scenarios were formulated by the regional government. So with this, we have 4 scenario storylines. So I'll just describe them briefly to you. One is actually evaluating the current planning process, so we'll call it business as usual, and the characterization of the land use models and ecosystem service models was based on the planning documents, both for urban development and for regional protected parks. And it carries a vision of what one could say sustainable development with urban planning, housing, transport, and also agriculture that meets agreed and negotiated goals of sustainability. There's one variant on that which I call local sustainability, which pushes things a little further by what I call here reinforced greening, especially pushing further urban concentration and sustainable agriculture and tourism. In contrast to those 2 other scenarios, one which we call rewilding, where essentially a lot of the mountain areas are pushed into conservation, so that agriculture is no longer supported, there is no more transport, and urban development ends up and business activities end up only in the valleys. In contrast to this, our other so-called pushback scenario is an ultra-liberal scenario where there is basically no constraint on profit-oriented economic activities, and essentially things end up concentrated in the few areas of the landscape, either mountain resorts or city areas, where things are most profitable. So we took these 4 scenarios and ran models for agricultural areas, urban development, and forest development, yielding, of course, maps of land use for this for each of the 4 scenarios. I won't spend much time on these today, just to attract your attention to the fact that, well, thankfully we got fairly contrasted outcomes for the 4 different scenarios, but that some of the main trends regard not the amount of urbanization, but where it's actually located. So I don't know if you can see the colors very well. The urbanization is the sort of darker gray colors on this map, and how much forest, there's no pointer here. How much forest in dark green increases in these landscapes, but at different patterns. So now let's look at and what I wanted to point out is that over this large area, 300 municipalities, that's quite large. In fact, we have very different dynamics of different what we call sub-sectors of that region, where we can identify current urban and peri-urban areas which are to some extent so developed that they're very constrained, so they don't move much according to scenarios. Some very vulnerable areas which happen to be some areas where there's currently a lot of agriculture, and which, depending on the scenario, can either have very serious urbanization or end up completely abandoned and reforested. And some of the mountain landscapes which tend to be more stable because either they become uninteresting or rewilded, or in any case there's not much interest for urbanization. So given these dynamics, we wanted to assess impacts on ecosystem services. Just to remind you as well, this has already been presented. In our case study, we chose to let the stakeholders tell us which ecosystem services they would like to see modeled and projected, and this resulted in quite a large range. Of course, as everywhere else, we combined that with our ability to model services and use a range of modeling approaches, which here using the topology that was developed in Grenoble 3.1, range from models that are quite sophisticated in terms of process incorporation to models that are basically simply related to land cover. So with this, we are now very proud to have what we call an atlas of ecosystem service maps for this region, where for each of the ecosystem services that we model, we have maps for, of course, initial state 2009, and the 4 scenarios for 2040. And this is what we can use now to analyze the trade-offs in space and time. So the first way that people look at trade-offs is what I call biophysical trade-offs, where essentially we look at how services, different ecosystem services combine in space. And here is an example from our results for the peri-urban part of our landscapes, where with such analysis we identified 3 ecosystem service syndromes, and which, not very surprisingly, tend to correlate very well with different types of land cover. So for example, we contrast areas in the peri-urban landscapes which have crops, and not surprisingly, where pollination and crop production are important, but as well as plant diversity, to other areas where other services come into play, and especially biodiversity. But in fact, this being a process where we want to advise on land planning, this wasn't really the things that people were interested in, these biophysical trade-offs. They wanted to know what would happen according to what they expect from these landscapes. And as part of the stakeholder involvement process, we got stakeholders to think about which ecosystem services they see as important, not only as important in each type of landscape, so contrasting forest, peri-urban, and rural, but how they relate to each other. And this is what we call ecosystem service networks. And this is what we use to actually assess the scenarios. With these in mind, we identified with the stakeholders as part of our third workshop how they would evaluate ecosystem service bundles according to their own appreciation of the importance of different ecosystem services. So for example, for the forest bundle to be at an excellent level, according to our group of stakeholders, there are 2 preconditions which regard the ability to protect from rockfalls in areas where there are cliffs, and the fact that forests produce wood. Well, that's what one would expect that. But also they incorporate a number of other conditions regarding the other ecosystem services from that bundle, and in this case give them very high levels. But you will see in this set of conditions we are with all terms, so they give alternatives to ways that a forest area can be excellent for ecosystem services. In the same way, for the rural parts of the landscape, they formulated rules. Not wanting to go through them here in detail, this is just to point out to you that they were able to formulate some fairly sophisticated multi-criteria rules combining the different ecosystem services and their levels at which they expected them. And likewise for the peri-urban area. So with these rules, we have rules for different levels of provisioning, so poor, acceptable, good, and excellent. We then went and assessed the scenario outcomes. So first of all, we applied these rules to the current landscapes, looking at spatial trade-offs, this time not from the biophysical point of view, but incorporating the stakeholders' rules to assess these landscapes. And essentially what this does is translate the capability of ecosystems to support the multiple ecosystem services that stakeholders expect from these landscapes. And this is actually a very interesting exercise because it's already allowed us to highlight, for example, some inconsistencies in the way that people thought about these landscapes. I'll give you a simple example. In France, and as in many places in Europe, foresters have a mission of not only producing wood and sequestering carbon, but also protecting biodiversity now. And this is a challenge for them. So they were very keen on incorporating, especially animal diversity, as part of the assessment criterion for the forest landscapes on the right. What we found is that this was actually incompatible because the idea of biodiversity was one of many species. As it turns out, forests in good ecological condition actually associated with some species, but not many species. And so this revealed a misunderstanding on their behalf of what would be a good ecosystem service bundle. And we have several examples like that. The point here is that with the outputs like these maps, we start to be able to discuss with stakeholders their understanding of ecosystem services and of their trade-offs. Now let's go to the scenarios. When we look at scenarios, one of the things that we can do is to look at temporal trade-offs. So we have the initial state of the landscape in 2009, and then we can compare that to various scenarios and relate that, of course, to the dynamics of the landscape, of the land cover. Just very briefly here, what we can see for the three types of bundles, the three types of landscapes that we have in this region, is that we have contrasted effects on the associated bundles. Interestingly, so the two, comparing scenario 1 and 2, which are the business as usual and the slightly greener version of business as usual, you can see that with a very similar land cover between these two scenarios, in fact, we have very different assessments of ecosystem service bundles. The one of the other interesting results here is that not all scenarios, well, there's no ideal scenario for all three spaces. We see we have for some of the landscape parts, the bundles vary positively in one scenario. For example, scenario 4, the liberal scenario, which stakeholders tend to think is really bad from their perspective, ends up with better provision of some ecosystem service bundles than other scenarios, including the planned scenario. Last point, of course, one can assess, as in the previous case, we can assess changes, temporal trade-offs, and bundles at the scale of the entire region. But what our stakeholders are rather interested in is how these things play out in space. In other words, how heterogeneous the outcomes of the scenarios are in terms of these ecosystem service bundles. And so if we compare, for example, on top two peri-urban areas of our region, You can briefly see from these pictures that the trajectories are quite different across scenarios. So even for similar, well, apparently similar or superficially similar areas like peri-urban in this landscape, we have different outcomes according to scenarios, and likewise for these two mid-altitude regions down the bottom. This is something that is repeated across the different types of bundles, where we start not only with different outcomes for the bundles across the areas in our region, but also very heterogeneous responses to the scenarios. And so these results are what we will analyze with our stakeholders in our forthcoming workshop at the end of next week. So to conclude, we can start very simply by analyzing the biophysical capacities for provision of multiple ecosystem services, looking at biophysical trade-offs and synergies, and these tend to be strongly linked to land use, land cover, not much surprise on this. We can also look at temporal trade-offs. For example, here, as there is a strong political drive for a plan that actually started to be implemented, we can assess this plan. Our work also helps thinking about the fact that there is no ideal scenario, but multiple pathways that the landscapes could take in this region, and also a high spatial heterogeneity in outcomes, which is part of why there is no ideal scenario. Through this work, we're hoping to demonstrate the value of stakeholder multi-criteria social valuation. As I showed you very briefly, our stakeholders were able to formulate some fairly complex rules that in fact reflect their intimate knowledge of this region and how it functions, but it also revealed some inconsistencies and an idealized vision of multifunctionality that they hold. So this was a bit of a surprise for us. We thought we'd be having to tell them that there are trade-offs, that you cannot have strong forest production, that they would focus on single ecosystem services or very few, but in fact they want too many. They've been pushed too much towards this idea of multifunctionality, and we're having to bring them back to reality of constraints and trade-offs. And finally, we believe that these types of results are really powerful to foster debate and learning, and this is what we'll do now in the next workshop, and as a final step, talking about all these results with decision makers. Thanks.